Let's do another exercise involving vectors. So here, find the position of a walker if on the first part of his journey he walks 6 kilometers across a field in a direction east 30 degrees south and then continues for a further 8 kilometers in a northerly direction. So here is the picture of the journey, the diagram of the journey. So first the walker walks 6 kilometers, so this length is 6 kilometers. The direction is 30 degrees east-south, and then it walks for 8 kilometers north. Now we can calculate the angle epsilon here, because here this triangle OA, and let's label this with the letter C, is a right-angled triangle. So angle epsilon is 90 degrees minus 30, which is 60 degrees. So now we'll apply the cosine law to find the length of vector W. So OB squared equals to, here the vertical bars means the length between points O and B, is equal to OA squared plus, so these are two adjacent sides of the triangle OAB minus the double product of the length of the two sides and cosine between the two sides. And now, after plugging in the numbers into the calculator, here I'll get the value which is approximated to two decimal places, 7.21. In further calculations, I will use the exact value which is stored in answer. I won't use the approximated value 7.21 by the exact value to find the angle of vector W. So here I can use either cosine law or sinus law. So let me use now sinus law. So the length of V divided by sinus delta, this angle here that we are looking for, let's label it with a Greek letter delta, is equal to the length of W divided by sinus of epsilon. So let's write it down here. So W, the length of W, doesn't work somehow. So the length of W divided by the sinus of the angle which is opposite to vector W is the same as the length of vector V divided by sinus of the angle that is opposite on the vector V. And we are looking for delta here for the measure of angle delta. So now let's rearrange this. Let's rearrange this here to get the value of sinus delta. After rearranging, we will get sinus of delta equals to the length of V times sinus of epsilon divided by the length of W. And after plugging in the numbers, we will get V is I believe it is 8, yes, V is 8. Sinus epsilon is sinus 60 degrees, and we'll divide it by whatever is stored in the answer, whatever is the length of W. We cannot plug in this value because it is approximated. We want to have the exact value of W. Or we can plug in here this expression, the whole expression, to here. So this equals to, I'll use the calculator to find it out. So it is 8 times sinus 60, sinus 60 degrees, because I have to make sure that the mode is set to degrees, not to radians, and divided by the length of W. So divided by whatever is in the answer. So here we have the value of it. It is 0.9 and so on and so on, 96 and so on, and we have to take, but we are not actually looking for this value. Here I made a small mistake. We are not looking what this equals to, but we are looking for the value of delta. So actually we are looking for arcus sinus of this value, arcus sinus, or the inverse function of sinus of this value. So here we have to take the inverse sinus of this value. Inverse sinus. So here's inverse sinus second, and this here, of whatever is stored in the answer. And that is 73.9 if we round it up to 1 decimal place, and in case of degrees we usually round it up to 1 decimal place. So it's approximately equal to 73.9. Okay, and now let's compare it with our program. If we measure it, we get exactly the same value as we calculated. And the length of W, let's measure this using our program. And the length of W, so here it's f, and f equals to 7.21. Okay, once again 721, and we also, I believe, calculated that it is 721. Okay.